So in lesson 6, we're going to talk about solving equations that have decimals in them. And we're going to talk about word problems that we set up and get decimals in those equations. And we're also going to talk about the consecutive integer word problems. So beginning with an equation with decimals in it, who remembers how we start these? How do we get rid of all of those decimals so we don't have to worry with the things that we don't like so much? Cooper? Yes, we're going to do that with any equation. And then when we have decimals, there's something special that we do to deal with the decimals. Daniel?
Basically, you just multiply them by just to get them all into the number.
So I do what? Say that again?
You gotta multiply it by 10.
Okay, so shortcut. You count how many decimals you see. 1, 2, 3. 1, 1, 2. The most I have is 3. So I want to move all of the decimals 3 places. So that when I move that one 3 places, that becomes 3 times x and I don't have a decimal in there. That means I am multiplying by 10 cubed or 1,000. But the main thing is, remember, count up and move the decimals the same number of spots. This one I have to add places in there to move it 3 places, so that becomes plus 400. This one I've also got to add a 0, so it becomes equal 2,050. Now you're going to do what Cooper said, go. Race me, see how fast you can do it. Get the x's on one side, the other things on another, and solve for x. I gave you guys a head start here. So we subtract the 400 on both sides, and we divide both sides by 3. And shout out, what did you get, everybody? 550. So, the trick I wanted to review was moving all the decimals the same number of places. Everything else is review after that. Thumbs up, we got it. Thumbs down, nod, or in the middle, we've got some questions. Looks like we're in good shape. Let's do a word problem now that has decimals in it. And I'm going to model 2 ways we could set this up and work it. Both are correct. Anytime we have of, that generally means times. 3/4 of x means 3/4 x. 0.017 of something means 0.017 times that something. So this says that we have some that were red dwarfs, and then we have some that were not red dwarfs. So whenever we have some that are and some that aren't making up the total, we think, oh, we could use a ratio box on this. So I could say red dwarfs, not red dwarfs, and total. So if I have 17 100ths, or no, I wrote that down wrong. When you stand this close to the board, it's easy to copy it incorrectly. Be sure you guys are always watching for stuff like that to help me catch it before we go too far. 17 thousandths. I left the 0 out when I recopied it. So if 17 thousandths are, how do I get the proportion that aren't red dwarfs? Taylor, can you help me out with that? Yes, because I have to add up to 1. And what would I get if I did that? So the 1's places have to add up to make a 10, so I can carry the 1. The others, I can just think they need to add up to 9. 7 and 3 is 10, 1 and 1 is 2, and 8 is 10, 1 and 9 is 10. And I have that 1. Then they tell me 29,000 total were examined. And I want to know how many were not red dwarfs. So I need something right there for the actual. My 2 complete rows then 0.983 over 1 equals x over 29,000. And I can do my cross product. 1 times x is x. And then I need to calculate or help here. 0.983 times 29,000. I am not going to do that one in my head. So be punching that in on your calculators and help me out. Kayla, you have it already? What you get? Anybody else getting 28,507? Okay, I'm seeing some heads. Not always good to have a backup. And that is how many were not red dwarfs. Now there's another way that you could do this. I'll go back up so we can read the problem again. 0.017 of the total stars, right? Is what that says. And then it says 29,000 were the total stars. So you could say 0.017 of 29,000, so times 29,000, were red dwarfs. Punch that on the calculators, and what do we have? Guys, what do you have? 493, and that would be were red dwarfs. So if we want how many were not red dwarfs, we need to take the total and subtract the 493, and help me out with that. What do we get? Did you do it on your, did you do it or work it out? Ethan, what you got? 507. Same answer. But either way, you have to be careful. Which one are you doing, are or are not red dwarfs as you think it through? Everybody good with that? Question, Ted? What'd you do?
It's 1 minus 0.017 times...
Yeah, that's equivalent to this. So you could have said the fraction right here, which we found right there. And that works too. So several different ways of writing it and saying it. Good job. All right, a little bit more vocabulary. This is going to be to help us set up various problems. A lot of times you'll have word problems that say, well, if the complement of an angle is 48 less than 3 times the supplement. And then they want you to find the angle. So they tell you things about the complement and or the supplement, but they want you to find the angle. The thing you want to find is the original angle, which I'm calling A. If they tell you something about a complement, that means that angle you want plus the complement has to be 90. So if we subtracted A from both sides, the complement would be 90 minus A. So when we set up a word problem, 5 times the complement of an angle, we're going to do 5 parentheses, and inside the parentheses, we're going to know to write 90 minus A. Similarly, if it's a supplement, we're going to write 180 minus A in the parentheses. Consecutive means in a row, in order, one right after the other without skipping. So if it's consecutive integers, that could be 12, 13, 14, 15. It could be negative 3, negative 2, negative 1, 0, positive 1. One apart, I've picked something to start with, and then I add 1 over and over. So n plus 1, n plus 2, n plus 3, n plus 4. Depending on whether the problem says you need 3 consecutives, 5 consecutives, or whatever you might need. Consecutive evens would be 12, 14, 16, 18. Negative 4, negative 2, 0, 2. They're going to be 2 apart. So you're going to start with an even one, add 2 to get to the next one, add 2 more to get to the one after that. Consecutive odds, 11, 13, 15. Negative 3, negative 1, positive 3. I still pick one odd one to start, and then every other one. So I'm still adding 2. The difference is, to be even, the first one has to come out to be even, and to be odd, the first one has to come out to be odd. If the problem says find consecutive odds, and your work says the first one is 4, then you know there's either you made a mistake, or there really are no answers. Now, one that gets a little bit tricky, I could do it this way for consecutive multiples of 2. I could do it this way for even numbers. But the way in formula 40 is the fastest, most efficient way. But if you start getting up to multiples of 17, so let's just suppose we want multiples of, say, 17. I could do, don't copy this down, I could do n plus 17, n plus 34, now it's getting harder, n plus 7 and 4 is 51, and you see how it's getting harder to set it up. Instead, what we could do is to say 17 times n, 17 times n plus 1, 17 times n plus 2, and so on. So whatever the multiple is, times n plus 1, n plus 2. Then we set it up, we go through our work, and maybe I get n is 5. If I use this formula, n is not the first multiple I'm looking for. The first multiple that I'm looking for is going to be n times that n. So in this case, 17 times 5, which is 85 if I multiply correctly here. And then my next one would be 17 times 6. And my one after that would be 17 times 7. But the book's going to give you some where it's not just evens and odds. They're actually going to tell you, use 7 times n, 7 times n plus 1, and so on. So they're going to help you, but remember that your answer n is not your first multiple. So everybody got those copied down? Okay, let's practice setting up some of those kinds of problems real quickly here. 3 consecutive, so in a row, evens. So I'm going to pick one to start with. I don't know what it is yet. The next one will be 2 more than that. And the one after that will be 2 more than that. And I've got 1, 2, 3 things listed there. So then I say 3 times, the sum, so I'm going to need a plus in there. What are the things I'm adding? I'm adding the first one of these and the third one of these. So n and n plus 4. That is 84 less than something, so I'm going to have to take 84 away from something. And the something is going to be 12 times the second one. Well, my second one over there is n plus 2. So then I do a little bit of PEMDAS and first simplify inside the parentheses since it's all numbers, or of numbers and variables. I'd say this could be a 2n. So this side is 3 times 2n plus 4. And Charlene, would you help me distribute that 3 times 2n plus 4? What do we get? And then on the right side, I also need to do some distributing there. Grazia, would you help me distribute on the right side, please? Excellent. And then I've still got my minus 84. And so you guys can race me and finish it here. That's going to become a minus 60. So I need to add 60 to both sides. And subtract 12n. Did I set that up right? That's what I meant to have there. see, I think I got something off there. So add that. Oh, I don't want everything on the left-hand side, do I? So we'll wait for a moment on that part. If I do this, I have 72 here equals the 12n. What I meant to do was let's subtract the 6n from both sides. So we have 6n. And anybody already done 72 divided by 6? What do you get? Shout it out, everybody. 12. That's my first number. What's my next number? We're adding 2. So 12, 14, 16. These are our answers to 6. Everybody good with that? All right. Since we have 2 sets to grade, I'm not going to do the whiteboard practice ones, but I do want to put something up just for you to look at and think about with a test tomorrow. Mr. Bell's writing this test, so I haven't even seen it yet. So I don't know for sure what's on there this time around. But usually on the first test, there are formulas that you need to know. Especially be sure you know surface area and volume for a sphere or a cone. Got the volume down there, so it could be either. Be sure you know area of a sector. Be sure you know arc length. All of those kinds of things. Look at your formula page. No formula note card. No open books when you're taking the test now.